Okay, good deal. Now that we have the contest taken care of. So last time we were starting our review, and I think we were in the middle of the proof techniques, which we have shown on the screen up here. And I think the last one that we did was, case analysis. Is that right? Case analysis, you proved 3.46 by case analysis on P. Are there any questions about that? One there that we were doing there at the end? Okay, and I've given you some homework back. Oh, here is this. Did this go around?
Yeah, they did.
Oh, right. Oh, yeah. That's the famous no-show. Okay, so next one that you can do for me. Do you remember how proof by contradiction worked? Yeah, to prove P, you prove not P implies false. So remember so here's the next.
Not P, and then you have to make it imply or equal to false.
Exactly. So let's do prove 3.47a. 3.47a by contradiction.
It's not that fun.
Took it down. Yeah.
So 347, what was 347? Here, let's see what 347a is. 347a is the first De Morgan. Oh, what's the
I
time?
win. 05:30. Take that.
Wait, was it 05:30?
To 7.
Yes. Playing Price is Right style. Wait, what are you talking about? I have to go over.
Ben.
You have to go
Ben.
under without.
You have to go under.
Yeah.
And I went under.
What was it?
05:30. I was 30 seconds
You
under.
can see that you are the subject of a contest.
Oh, you're right.
Okay.
That's good, that's good. Hold on.
We're a little off topic here, you guys.
Alright.
So let's get back. So let's get back. The 3.47a is the first De Morgan law, right? And we want to prove it by using proof by contradiction. Actually, you guys who've been around a while, who are doing the camera work, you remember we did proof by contradiction to prove the halting problem is undecidable. Remember that? So how do you set up 3.47a? How do we do that?
Not the whole thing.
Yeah, you do not parentheses the whole thing, right? So get out a piece of paper, pencil, get to work. This is a workshop. Yeah, let's do a cut. So let me see how you're doing. Just keep working there.
You snoop on my one.
Not, I am.
That's right.
Are we good?
Yeah, so normally I'm just, starting at 3.5 and then going until whenever you just come back in and then I'll just cut that part. Okay. And see, we're like 7:30, no, 4, so plus 3:30.
So what can you do with the not in front of the whole thing? Where do you start? Yeah, you can distribute it to whatever side. And what side should you distribute it to? I think the first one or the second one? The left side or the right side of the equation? You think? I don't think so. I think the left side, because if you do the left side, you'll have double negation right off the bat.
But aren't there parentheses on the left side?
Well, yeah, but,
Oh,
but it's out in front of the whole,
Yeah.
because that's what makes it good. I mean,
Sure.
Give me a warning, all right?
all right. How's it going?
Rusty.
So I think after you do the double, has everybody got the,
You can make it equivalent, not imply, right? False?
Yeah.
yeah, because if it equivales false,
It does.
it also implies false by mutual implication. Okay, so then after you use the double negation, then what do you
Use
do?
anything later than De Morgan A.
Correct.
Yeah.
After that, you get rid of double negation, and then you De Morgan's.
No, you can't use De Morgan B.
Use the golden rule.
Use the golden rule to get rid of the what? Yeah, to get rid of the conjunction, yeah.
Do we have to do this on a homework assignment?
Yeah? You did this once before.
We did do it.
Is this a long one?
Yeah? Okay, well, maybe let's cut in.
332.
Let's cut in.
Use 332. Ready?
Yeah.
I love 322.
332 is pretty dope.
Yeah, and I think, so you've got it to the point where you did the double negation and you use the golden rule to get rid of the conjunction, right? And now you got to use 3.32. Yeah, that's the next little step there, right?
You replace it with anything?
Sure, you can.
You know,
You can get rid of the P and you can get rid of your
Yeah.
not P or not P.
okay, so work on that. I think you might have to use 3.32 twice.
Probably.
Okay,
With periods like you and move.
another fade out here.
We have to get to equal value false anyway.
Either equivalent or imply.
Well, can't imply because we can't use imply yet because we have.
Oh, well, that's interesting. Yeah.
Yeah.
Oh, that's
I feel like we
interesting.
had this discussion
Yeah.
in deja vu,
Deja vu all over again.
pretty much.
Is the street structures gonna be in this class next semester?
In this room, I think it is. Yeah,
That's the one I'll be.
yeah, yeah. Do you know yet if you can, is your schedule done?
It all depends on,
So still, we don't know yet quite. Yeah, okay.
it all depends if I'm thinking athletics people get there, take all of our spots.
Yeah.
Those athletics people when you're taking the
science.
computer science
And
classes.
What's that?
Really?
That's true.
I'm going for great flips.
Which one?
4.
Yeah, well,
Marshall.
Okay, so how are we doing on 3? Did we get it?
I did it once, but
You did it once, but you didn't, not this time?
looking at the second time.
Yeah, I got it.
Oh, good. So how did you want to share the wealth here?
Sure. So where are we at? Double negation?
Or golden rule.
So after the golden rule, then what did,
You use
Oh, I got it.
332 twice.
yeah,
First time you use 332, you use P and Q, so you get the P equals P, just goes off because it's true.
so you didn't have to do any replacement, you didn't have to do any textual substitution the first time you did 332?
No.
So which ones did you have?
So
The
I
P-
ended up having Q.
The P or Q and the equivalence P?
Right, and so the P leaves.
And so the equivalence P, you get rid of that,
Right.
that way.
And then.
Did everybody see that, what he's talking about?
Sure. P or Q.
You know that P or Q equivalence P, you substitute equals for equals and you replace that with, you substitute P or not Q.
Yeah.
But then the second time, do you have to do with P replace not P or something like that?
It's let's see,
Or PQ?
P replaced by no, P stays the same,
Oh, P stays the same.
and then you replace Q with not Q. But it's actually switched around, so it's actually P is replaced by not Q and Q is replaced by P.
So it's PQ, the way you write this is you always do P comma Q replaced by what?
Not Q.
Not Q, P.
Not Q comma P.
Yeah, and so what you get after that is Q equals P equals not Q, and equals not P or not Q equals not P or not Q, so that's just true. So that cancels out.
Ah, so you use a 3.3.
Right. And then you're left with
And then
Q equals not Q equals P, and Q equals not Q.
That's probably a 3.15.
15, so that's false, and false equals P is true.
Wait.
Wait.
No, hold on. False equals P is not
It's
false.
not, it's not. Bummer. That's where I'm at.
Oh, whoa, did you make a mistake there somewhere?
No, I just assumed that false.
False equals not P means P equals true.
Yeah, that equals P, is that right?
No, I have false equals P.
Oh.
So it should be.
No, that can't be right. If you have a not P equals P, then that would be false.
I don't. I have a false equals not P.
Oh, well then you must have made a mistake somewhere because it needs to be, yeah.
So back up at the first time we used 3.32, I don't get why we can drop the P off.
You're substituting P equals P or Q.
Sure.
P equals P or Q. You're substituting all of them.
So
Oh,
that equals P or not Q.
I'm lost in the second one.
Wait. I thought after we did 3.32 the second time, we just get not Q equals Q.
Oh, if that's what you get, if you get not Q equals Q
Then that's just false.
by 3 point,
1.5.
yeah, by 3.15, that is false.
Wait, where are we?
So you did get it.
You
I
get
didn't
not
get the
Q
second.
I'm 3.32.
not seeing the second
with
thing.
P, not P replaced by not Q and
Oh,
Q
right,
replaced
right.
by P.
Yeah.
Not the second one.
So what about not Q?
So the second one, what is the second one? Let's write it down. Is
What
it,
about the P?
The P?
Not
The
Q.
P's gone.
The P is the not Q.
No, but you put another P in.
No, you don't.
Oh, the P is the not Q.
Yeah, the P is a not Q.
you know what you should do? You should write it out. In your hint, look you guys, in a complicated one like this, in your hint you should say this. You should say 3.32 you should say 3.32 with PQ replaced by, what did you say? Q not P?
Not Q, P.
Not QP, and then you should write that out. Write out what 3.32 is. If you write it out, then you know, here, write it out. Because if you write it out, then you'll be able to see. You have, instead of trying to see it in your head, sometimes it helps to write it out so you see it on paper, and that way it's more.
That's it.
It's. Are you with me?
Yeah.
See, right, here's my, this is really good. So many people want to do so much in their head.
Our head's only so big.
Yeah. So it sounds like everyone's pretty, did everyone get it?
Well, working it out.
Still? Okay.
It's just
Keep,
that and then 315 you're
Q or
done.
Q, not Q or
Okay, how, still have a couple, Cale, you got it? Oh, you got it?
I don't get not Q equals Q after that.
You should use both of the or terms to just get a not Q left over.
Ben, can you take,
Yeah.
Not Q or not.
show, can you help out?
So you got P or not Q equals Q equals not P. Okay, so
Right.
what you end up with is putting 332. You'll have, this is what you're substituting in. So you'll have
I'll
that,
just proof
you'll
on
have-
the test.
Oh, now you can advise me what to put on the test? Okay, I'll just let you write it, how about?
Yeah, you should put this on the test, it's awesome.
Okay, got,
I just copied down this text.
oh, you just, oh, okay, okay, so now you got it. Is everybody good? We're all together? Okay, good deal. All right. Next one is, next proof technique,
Contrapositive.
proof by contrapositive. Okay.
Prove not Q implies not P.
So to prove P implies Q, you prove not Q implies not P. So prove 3.76C. Prove 3.76C using proof by contrapositive. Okay, oh, before we do this, let me give you a little quiz. What is the converse?
Oh, man.
The converse of P implies Q is
Q implies P.
Q implies P. The contrapositive of P implies Q is
Not Q implies not P.
not Q implies not P. So I have a question. Is an implication equivalent to its converse, yes or no?
No.
That's correct, it is not. Is an implication equivalent to its contrapositive, yes or no? Yes, that's what we're using here. Okay? And we all know that P implies Q is not the same thing as Q implies P. If I win the lottery, then I'll buy a red Corvette. Does not mean if I bought a red Corvette, then I win the lottery.
Now, can we use the contrapositive like as a step in any proof?
You can, because it is a theorem.
So we can say contrapositive and then switch it all around.
Yes,
Okay.
yes,
Whoa.
you can. But the way we do proof by contrapositive is we write down the contrapositive at the beginning, and then we say, okay, prove it. And you can. And by the way, once you write down the contrapositive, then you can use any. You could use like assume conjuncts of antecedent, or you could use whatever you want.
Right.
You know.
Is there a theorem that has contrapositive?
Yeah, in fact, it is. Here, let's look it up. It is.
Let's just quote that.
It's 3.61, right? 3.61 is P implies Q equivals not Q implies not P. That's 3.61. So, yeah, that's the justification for this.
Yeah.
Yeah. All right, so 3.76C. Let's see, what is 376C?
P and Q.
Implies P or Q.
It does.
I remember this one.
This is a weakening strengthening, huh?
Yep.
So, you write down the contrapositive.
Assume the conjuncts. Except there are no conjuncts, they're disjuncts.
No. They will. Well, after
Once you
you
take the contrapositive, it's not.
do, can we use De Morgan?
Yeah.
Yeah, but it'll turn into disjuncts.
Oh,
No, it'll turn the antecedent
Use
into a
strengthening and then
conjunct.
weakening, and then the Morgan's again, and you don't.
Wait, can we?
Wait.
We can't assume the context
No, you can't-
after we've
Right,
manipulated it.
right. You can't, yeah, you can't do that.
Sure you can.
After you've, well,
Well,
It's
it is
equal-
equal.
It's equivalent. P implies Q, equivalence not Q implies not P.
And so if it's the same thing, then
Then we can prove not Q implies not P using, assuming the context is equal.
well, yeah, actually you can.
sweet.
But there's a different way to do it.
Of course there is.
This
Always is.
proof is actually.
Actually, I think if you start with I think it's better if you start with the left hand,
Yeah.
if you,
And get it
and get it to imply the right hand side.
Yeah.
And then it's real simple.
Take a look.
That's a better style. Yeah,
Nice one.
yeah. So here's what you do. You write down the contrapositive, right?
Sure.
And then start with the left hand side and get it to imply the right hand side.
You mean the right hand side?
No.
Left hand side and follow. it.
Start with the left, after you've done the contrapositive, the way you prove it is start with the left hand side and get it to imply the right hand side. Yeah,
No, because you have to use your answers to get this one. And we use the whole thing, and then we use.
Well, I know, but look, there's, now I'm saying, now I think it's nice to,
True or true?
Do the other way.
That's what I'm doing.
4 steps to do it that way.
Conjuncts antecedents like 2 steps.
Not here, not here.
it's no advice from the camera gallery here. You're going to cut that. That's pretty good. Whatever. I'm at the mercy of my cameraman. I'm liable to be cut at any time. That's pretty good.
I don't know if the final cut to reverse it.
How do you want us to do it?
What I recommend you do is first write down the contrapositive, and then start with the left-hand side of the contrapositive, and get it to imply the right-hand side. Yeah? Because if you start with the left-hand side, first you can use De Morgan's law, right?
I like the way I jacked this last time.
Well, okay.
That way works. It's good.
Wait, or does it? Hold on, because you would have not P, you would have not
De Morgan's, 376B, 376A.
6A.
De Morgan's, done. It's awesome.
Oh, yeah, it is nice. It's quite nice. You introduce the P with the weakening, or the Q rather. No,
Let's use the Q with.
you introduce the Q with weakening. Yeah. Oh, that's quite nice. That is quite nice. Yeah,
Q back.
yeah. That's quite nice. Or you can just do the whole. You can do the whole thing if you want. Okay, are we all good? We got that one all right? Okay, so much for the proof techniques. How about this? Joe fails to submit a project in course. He said,
Oh no.
if Joe fails to submit a project, then he fails the course. If Joe fails, then he cannot graduate. Hence, if Joe graduates, he must have submitted a project. So if S is Joe submits a project and C is F is Joe fails, G is Joe graduates. Okay, so here's your job. Here's your job. With these letters, with this argument, and these letters for these phrases, write down the logical argument.
Yeah.
Okay, so do that. Write down the logical argument. Can you do it? Are we we got it? If Joe, then he fails.
It's not a whole lot of time you gave us.
Well, okay. Take another 3 seconds. 1001, 1002,
Writing down that facts
1003.
already.
Yeah, it's always, a logical argument is always fact 1, fact 2, fact 3 implies conclusion, right?
Yes. Conclusions.
All right?
Yeah. Ja.
Jawohl, mein Herr. Ja. Sprechen Sie Deutsch? I see you know one word. Oh.
You just wanted us to write it down.
Yeah, what is the argument? Write down the whole argument. What's the argument?
Not S implies F,
And?
F implies not G, implies G implies F.
Oh, I guess I don't have this on here.
Body fellows.
Say it again? Yeah, because there's nothing, since it's not a proof.
If Joe fails to submit,
Okay,
then he
so
fails the course, so not S implies F.
not S implies F.
And then if he fails, no graduating, so F implies not G.
And F implies not G, not G. Okay,
And then if graduates, he must have submitted a project, so, no, not and, so it all implies.
oh, it implies,
G implies F.
G implies S. Do you think that's a valid argument?
Yep. Because we already proved it.
Looks right.
Yeah, I think so, because if we start with the left-hand side, we know that S implies F and F implies not G implies what?
Not G implies.
Not S implies not G, but that equivalents
By contrapositive,
by contrapositive, G implies S.
Oh my god.
Are we good?
That's like the shortest.
Oh, wait, so that's not proof right there?
So what's
No,
the
no,
actual
what-
theorem that lets us say,
We're gonna prove it.
That's like transitivity.
Well, we just did,
is implication and
verbally.
conjunction transitive?
Yeah.
Say it again?
So if S implies F, and then F implies not G, we can just say not S implies not G.
There's a theorem for that. It's a P,
3.82a.
Sure is, okay.
yes, 3.82a. P implies Q and Q implies R implies P implies R.
Yep.
Okay? How about this one? I remember this one's on the slide on the next one I press the button. If X is greater than 0, then, if Y is greater than 0, then Z is 0. Holy cow, isn't this one of those?
It's a big one.
I mean, it's an if something, then something. So it's a implication inside of an implication, right?
This big thing.
So little x, so what is it? Can you write that down? Write this one down. What is it?
X.
X implies Y implies D in parentheses.
X implies, Y implies Z in parentheses,
And Y
and Y,
implies
the whole thing implies,
X or Z.
yeah. Is this what everybody got? X implies, Y implies Z, and Y implies X or Z. Is this a valid argument? What do you think? Is this a valid argument? How would you, I think it might, oh, is this the one? Oh, I remember one of these was a counterexample. I mean, one of these was not valid.
False.
This one.
And if X and Z are false,
No, I think this might,
X and Z.
yeah, which one was
false,
this?
false implies false is true, true, and true is true, true implies false. Yep.
Yeah.
This does not work? You found a counterexample?
X and Z is false and Y is true.
Yep.
Okay, so X, false,
Oh, Y could be anything, right?
No, it cannot.
Y, true?
Y true.
Because you know, false implies true.
Y,
It
true.
has to be true implies false, and so Y has to be true in order to make the whole thing true. Unless
So
you
this
put
is-
false in.
This is a counterexample?
Yes.
Are we all good?
What about
No,
Y is
no.
false?
X and Z are false, and Y is true. Yeah, you're right. Never mind.
What if we put Y as false?
False implies false is false. False implies false is false.
Oh, I
false
didn't see
false
that
is
and,
false.
right.
But false implies false is true.
Yes. I didn't see that.
False implies false
I missed
is
the word
true.
and.
False implies false.
So this is a counterexample to this? Is that what you're claiming?
True is false.
It is.
And
Is everybody good
Uh-huh.
on this little review? Are you good? Okay. So here's examples. Oh, remember Portia's Suitor's dilemma?
It's in the gold one.
Portia's da 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 da.
It's in the gold one.
It's in the gold one. That's all we need to know. Oh, did we prove that Superman does not exist? Yes or no?
We proved it's a valid argument.
We proved it was a valid argument. We did not prove that he does not exist.
Therefore, if you
But I don't think Krypton
Believe-
exists.
If you believe all of the facts,
believe all the facts,
then you don't exist.
Yeah. Okay. How about this one?
He is a knight. Someone has to feed.
Let's set up each one of these and see if we can. Remember the thing here. If B says a statement X, this gives rise to the expression B equivals X.
Sure.
By the way, I had a really interesting discussion with one of you guys in my office about this problem.
Sure did.
And well, actually, let's. I'll relate that when we do part C. Let's do okay. We are assuming that everybody on that island is either a knight or a knave, and we assume that knights always tell the truth, and knaves always lie. That's our assumptions for this whole thing.
knights cannot say I'm an
So if B says something, X, then B equivals X. Because, and this is true whether B is a knight or a knave, whether he's lying or telling the truth. Because if he is telling the truth, then this is true, and we have true equivals true. But if he's lying, then this is false, and we have false equivals false,
Yeah.
which is also true. See? Okay, so how do you set up A?
B equals.
So this is
B implies
5.6A. 5.6A. Someone asks B, are you a knight? He replies, if I am a knight. So who's talking?
Could someone say I'm a knave?
No, that's not.
You can
allowed.
say whatever you want.
No, you cannot say I'm a knave.
I'm an knave is an impossible statement.
In this scenario, oh, that's a good point. Like, yeah, that's a very good point. That's the heart of the discussion that we had. If somebody says, I am a knave, he cannot say that under our assumptions because we are assuming that knights always tell the truth
And knaves always.
and knaves always lie. So under those assumptions, that is...
Those aren't assumptions, it's fact.
Those are.
No, that's an
Well-
assumption for working these problems.
It's a fact on this island.
Yeah.
We assume to be true.
So,
We
if
assume
someone-
this island exists.
But
someone on the island
But that
said
fact, but if somebody on the island says, I am a knave,
They're an idiot.
no, then our assumption, because
Lie.
our assumption is not right.
We no longer assume.
Because he's not always telling the truth or always lying.
Yeah.
Or
See?
he's not a
So
knight.
you
If
can't,
someone says that,
if you say this
it implies
statement
our
here,
entire-
if you say this statement,
Not a knight or a knave.
this statement is not true.
No.
He's a turtle.
See here. This statement is not true.
Be a jester.
Is this statement true?
This statement is not true. But it,
No, we can write this down.
is it true?
Well, the problem is, if it's true, then what it's saying is true and it's not true. If it's not true, then what it's saying is not true and it is true. So it's a self-contradiction.
What a scary statement. I hate things that
Are you
talk
with
about
me?
themselves.
All the
It's a hunting problem all over
it's
again.
like the other statement.
So vain, they talk about themselves all the time.
So this is a meaningless statement. It's self-contradictory.
Don't ever write that statement again.
But we are assuming that we are assuming consistency. See, this statement was inconsistent with itself. We are assuming consistency here, that knights always lie and knaves always tell the
Yeah.
sorry, knights always tell the truth and knaves always lie. So anyway, let's do 5 points. So let's set it up. Someone asks B, "Are you a knight?" He replies, "If I am a knight, I'll eat my hat." So
Equivales.
B equals, because he said, now what did he say?
B implies hat.
B implies
H.
H.
Or D for delicious.
Delicious.
Prove that B has to eat his hat. Can you start with this and get H out of that?
We just have to get H out of it.
Well, it says, prove that he has to eat his hat.
So we just have to prove he's a knight.
Well, maybe, maybe not. We just have to prove that he has to eat his hat.
Yeah, you can't prove that he could be a knight or an angel.
Well, I'm not sure. But how would you do
I
this?
just recall.
Well, yeah, you just remember. How would you do? What do you want to get rid of? You want to get rid of the implies. How do we get rid of implies? There's 3 ways to get rid of implies. There's our old.
3.9?
Well, but the problem with 359 is, I think what doesn't one of those implies has an equivales in it, right? Or two of those.
357.
And I think what you want to do is get it with an equivales B.
Sure does.
I guess.
Oh, never mind. Oh, then 360. Yeah.
Is everybody following this all right?
Yeah.
What's 360?
P implies Q, so B implies A. Equivales P and Q equals P, and the P would be B. So we can get rid of it all and just say
And you will wind up with what?
B and H.
B and H. So therefore you got H. Oh, and by the way, what else do we know? What else do we know? We also know B. So we know what?
Wait,
That he is a knight.
So once we get B and H, what theorem would we use to?
Well, you can just stop right there because you've shown B and you've shown H.
Oh, so there's no, you don't have to continue the proof at all.
Okay, what you do is this. Equals by, what did you say? 3 point what?
160.
3.60.
B and H.
B equivales, and what is this?
B and H equals B.
B and
It's not
H
even B equivales, we got rid of it all.
equals B, right?
Drop B.
Yeah,
Drop all of it.
drop the B's.
It's just B and H. You don't even
Yeah,
have to do anything
sorry,
else.
you're right.
Oh, in one step, right. Right. We can substitute the,
B is P and H is Q, and there's an equivales P after the P equivales.
no, wait a
B
minute.
and H.
It's P implies Q equivales P equivales.
Oh, I see. So you just get B and H right off. We don't have to use 3.3. Yeah, that's very good.
Aha.
So what I'm saying, so what we're,
B and H.
so it means B and H.
So
It
both
means
B and H are
B is true and H is true. So you know that he
As
has
long
to,
as B
you
is
know that
false.
B is a knight, and you know that H has to, and then you know he has to eat his hat. Right? Okay, let's set up part B.
I just thought how you can just know just because it's.
Well, because you have established, starting with this, you have established B and H.
Have you established? Start it with a true statement.
Okay, look,
Start out with a
if you
statement.
want, okay, here, Ben.
Because we're assuming the statement earlier.
Yeah.
Okay.
Okay. Now, if you want, you could use strengthening and say this implies, what is strengthening?
Either one. Yeah.
Yeah, it could imply B or H.
Yeah, so you could imply using strengthening.
Yeah.
Can
That-
you
that
say?
doesn't-
So then well, if this is true, then he has to eat his hat. But I mean, you can just stop right here and say, oh, we've established B and H. Once you get a conjunction, you know each one. But once you get if you have a disjunction,
Ask me one or the other.
you don't know anything.
Because nothing.
Diddly. Okay, let's do the next one. Inhabitant B says of inhabitant C, if C is a knight, then I am a knave.
E equals C.
Wait, who's talking?
B is.
Oh, B is talking? Okay. So
B
B
says
says
C implies not
B.
B.
C implies not B.
Yep.
One of these is like you can't really tell.
But he just said I'm a knave.
Oh no, that's the
And he
next
can't say I'm a knave. So it means C must be a knave.
Well, let's do some,
C's a knave.
don't do case analysis. Let's use our theorems. Same theorem,
Yep.
only this time we have to do,
Oh, no, we have to do 3.59.
Yeah.
I don't think so.
Sure does.
Do it. Do it.
3.59. P implies Q equals not P or Q. No, wait. No, it's the definition. 3.57.
Don't we want to get an equivalence not B or an equivalence?
You could use it.
I don't think 359 is good.
Can we take the contrapositive of just the implication? Yeah, sure we can.
Yeah.
And then we can
That's
use
a good idea.
something else. One of the other 3.59.
And you have B implies.
Well, I mean, why don't we just use it right off the bat?
Because we have
Why don't we use
Yeah, turn into B.
C-
B implies not P.
yeah,
And then you use the
Go-
same.
go with that idea.
and then we have the same
Why don't you
thing
use-
we had last time.
Not C. Which is.
So you want to use contrapositive?
Contrapositive, we'll get B equals
Okay.
not, or B equals B implies not C.
By contrapositive, B equivalents what?
B implies, or not B, but we know that that's
Yeah,
B.
okay.
Implies-
Contrapositive and double negation.
Sure.
So B implies
Not C.
not C
And then we can use 3.60 again,
equals by,
and we'll get B and not C.
so we'll have B and not C. Oh, so now we do know that B is a knight and C is a knave. Oh, nice one. Okay. It is rumored that gold is buried on the island. You ask B whether there is gold on the island. He replies, there is gold on the island if and only if I am a knight. So who's talking?
B.
B is
He's the
talking.
only one who ever says anything for some reason.
I think this one. There's gold on the island, but you can't tell if he's in
B
there.
I think
equals
maybe-
B.
B equivalents, there is gold on the island if and only if I am a knight.
So G
So G
equals
equivalents
B.
B.
See, you can prove that G is.
Yeah.
By
On
3.3.
the island?
Yeah, but you can't prove
3.3
what
G
B is.
equals true.
No. Oh, yes, by 3. So equals by 3.3.
Twice.
Well, let's do it. Let's do 3.3. It's
And then G equals true. You just use
Oh.
B equivalents B is true, right?
if you want to get it caught.
If
So
you
that's
just-
true equivalents G equals by 3.3 G, right?
Sure.
Let's go on the island.
There's gold on the island. You don't know.
I want to prove what B says,
You don't know if he's a knight or a knave.
but
No, you don't. I thought.
there isn't gold on the island if his statement was false, which means he must be a knight.
No.
He's a knight. That's not
Yeah, that's
No, he could be, he could,
has to be a knight for that statement to be true.
So
So
you have to
if
assume that he's
Is
a
it-
knight.
if there's-
no,
is it
he
gold
doesn't.
on the island?
Only
No,
if
he
he's
doesn't.
not. So if he's a knave, he'd be lying about himself.
he says there's gold on the island if and only if I'm a knight. So
Yeah,
if
so
we
that-
prove that there's gold on the island based on that statement that he said,
Well, he-
we have to assume that that statement was true, which means it's a knight because
Yeah, well,
No.
It's true because he's saying if he's, because if he's a knave, then he'd be lying about himself being a knight. He
yes.
would have to be
Because
going
B
on.
can be false or true and it's still.
There you go.
yeah, you're right.
Touche.
So it doesn't matter whether or not he's a neighbor or not.
All right. So, we all set?
Let's take it right now. Sit.
See you at the exam on Thursday.
Tomorrow,
And
6
cut.
o'clock at your place?
Yeah, and you want to, yeah, we don't need this for the film, but